Welcome to listeners. It's P.V. Murthy, Associate Professor in CSD Department at MLRITM. Today we start a journey into the course Oops through Java. In particularly, I start with the introduction to the Oops paradigm. Why we required these Oops concepts and how we are going to implement these Oops concepts in the language Java. When come to the OOPS paradigm, this object-oriented programming system is a programming paradigm centered around objects and classes. Popularly, this OOPS, we call it as a OOPS concepts uh, with reference to the object-oriented programming. Why we are using, how we are using these objects and classes efficiently in developing the use enterprise softwares. What is the main goal with concentration in the OOPS is this writing the programs in OOPS rather than writing procedure oriented codes that operates on data. This OOPS organizes all programs around objects and combine this data and behavior of the particular objects in the OOPS. This approach, writing this data and behavior around these object concepts, this approaches mirrors how we are thinking about any particular object or any particular operations in the real world, making code more natural, reusable, and maintainable. When you are developing particular codes with reference to a real world, the code becomes automatically more natural, reusable, and maintainable. What is the meaning of this concept in particularly when compared when reference with the real world entities or real world is we call it as a real world modeling. This real world modeling presents entities as objects with properties and behavior. Every object is having its own properties and it behaves on its own. So we concentrate based on the real world modeling, identifying as real world entities. Then it reduces these OOPS concepts, reduces complexities. In what way it reduces the complexities means it breaks down large problems into manageable modular components. So this whenever we divide a given problem, in particularly the large problems, into small manageable problems, we can apply the modular components or modular concepts. So it becomes easy to develop, test, and debug. Similarly, whenever we identify the using the OOPS concepts like an objects or real world entity objects, it promotes reusability or it promotes reuse of the code. That means once we develop any particular code for the small objects or entities, that entity can be written once and can be used many times across different projects. It need not be the same projects wherever necessary because we developed the code based on the real world entity. The real world entity can appear in across many projects so that the same developed code can be used across different projects. That is one of the main feature of the OOPS concepts. Then it scales efficiently the application development or project developments. So it is ideal foundation for building large enterprise applications. So whenever necessary, we can expand the given application or a project easily when compared to the other programming language. That means we need not start from the scratch. we can extend as and when required. So based on these real world entities, the requirement of the developing the huge large projects or applications, it around four different properties or characteristics of object oriented programming. So the characteristics of the object oriented programming are fundamental to its design and functionality of the application or project. These properties includes encapsulation, inheritance, data abstraction, polymorphism. Now, in this particular class, we see briefly about all these four characteristics. Then we'll concentrate in detail about how we are going to use and how you are going to develop projects or applications around these four characteristics, because these four characteristics are essential for developing any applications in the object oriented nature. Right, the first is the encapsulation. What is the meaning of this encapsulation characteristics of OOPS is it builds or building data with methods and controlling access. What we are doing here, we are building data with methods and controlling access. What it means we are binding the data and functions together. We are binding data and functions together so that functions can operate on the data, right? So it ensures no other part of the code, no other part of the code can access this data except that function. So if you want to access that particular data, we need to use this function. Without this function, we can't access, or else it avoids other part of the code can access this particular data. This is called as encapsulation. Then data abstraction. What this briefly the data abstraction means, we are hiding all complexities uh, to the user or end user, and it shows only the essential part of the code to the or essential part of the application to the end user. So it shows only essentials, it hides all complexities. So providing only essential information about the data to the outside world or end users, and hiding the background details or implementation, it makes easier for development or utilizing the given application. So that is one of the feature we are going to use, that data abstraction, hiding complexities and showing only essentials, right? Then the next thing is the inheritance. One of the main feature of the OOPS is reusability. So we need not start with the scratch. Previously, we already developed or tested successfully a part of the code or a code. That code can be used n number of times in the remaining projects wherever necessary based on the real world entities. So reusing the functionalities of existing classes to the new classes or allowing for creation of new classes that inherits properties and behaviors from the existing ones makes that application development easy. So it gives reusing the available codes so that we can easily build any complex tasks using the existing tasks. The next property is polymorphism. What is the meaning of polymorphism? Okay, we are creating a real world entity, but that real world entity may behave in the different situation in different ways, but basically same entity. Okay, we want its multiple forms. Object may behave in multiple ways, or objects taking multiple forms, right? Based on the situation, it acts differently. So allowing objects of different types to be treated uniformly. Same object, maybe the different types of behavior. Okay, but we are going to treat this particular object uniformly, enable flexible and extensible code development. What makes this? Because basically the object is same, entity is same, but it behaves differently based on the situation. If you are using this polymorphism characteristics, it makes the code development flexible and extensible. Okay, so in what way we can say, for example, you can identify a real world entity is a car. That car can be treated as an object. So it has the properties. The properties can be color and speed, and it may have behavior like start and stop. So what we identified in identifying the real world entity as the car as an object, the real that means the real world entity is the car. The car is having few properties, and it is having few behaviors or methods. The properties are called colors and speeds. We are including in the code development or object development, and we are including a few behaviors or methods like start and stop. So here we need to concentrate how the objects are related to real world examples. All objects we are going to relate with real world examples. That is the main thing whenever we are creating any objects. Right. So, in the objects, whenever we are creating the object oriented programming, whenever we are creating any objects, we are having the two properties or two building blocks. Okay. One is called as the class, other is called as object. Okay. Now, we'll see what is the meaning of this class, what is the meaning of object with reference to the real world entity. So we identified a class as an entity. The class, what is the meaning of this class is the class serves as a blueprint. Clear? So first, whenever we identified any real world entity, we are identifying what are the properties of that particular real world entity, what are the methods, how that entity will behave. All behaviors we identifies. Okay, that properties and behaviors, everything we are going to include in a template for creating objects. So the creating template for the objects is called as class. So the class includes all required template information for creating the objects. So the class defines the structure. The class defines the structure. The structure includes attributes and methods. Okay. So the methods we call as capabilities. The structure represented with reference to the attributes and methods we can identify as capabilities of the real world entities. So the class defines the required structure and capabilities. In other words, we can say the attributes and methods that objects of this particular type will have. The object of this particular type will have. So whatever the objects we are going to create, whatever the maybe it is having the polymorphism different types, we are going to identify all the required attributes and capabilities that object should possess. So think of it as an architectural plan. So it describes what it will be built like. In the here this particular diagram is indicating architectural plan for building a car. Okay, so for this particular, if you want to build this particular car, we require an architectural plan. So how we are going to assemble, what are the parts required, in what way we are connecting each together. Okay, but be careful, but it is not actually building itself. it is giving only the plan. The actual car will be built based on an instance that created based on the class called as object. So an object is a concrete instance created from the class. So for creating the object is representing the car. For creating this object, we required a solid class that includes all required basic structure and capabilities. So this object is a concrete instance created from the class. If you want to build an object, we required a class. So if you want to build a car, we required an architectural plan. So it is a real entity in the memory with its own state. That means its own value of attributes. The values of attributes can be changed from one object to other object, or from one car to the other car. Say for example, one car may have one type of color, maybe the red. Other car may have its own color called as maybe the blue. Okay, so every object is having its own state, that value of attributes, and its own behaviors, the methods what it can perform. So every object may differ from each other, but all objects are instantiated from the same class. So using the same blueprint, we are creating different class with the different attributes and behaviors. So multiple objects can be created from the same class with unique attribute values. Okay, right. So what we required in creating this particular object in OOPS paradigm, uh, in using the use concept, first we are going to define a class. So the class is based on whatever the architectural plan. It can be a car, it can be any other real time entity. So basically, we require a basic plan. Based on the basic plan, you are going to create, or you are going to define a class as a blueprint with required attributes and required methods. So we are going to have n number of attributes and methods that can be included in the definition of the class. And that means, say for example, in this particular code is representing a class. This class, we are defining a real-time entity called as the car. Here, for example, we included one attribute value called as color, and we included one method called as start. Okay, similarly, we can include n number of attributes, we can include n number of methods. Each and every method will be clearly defined, what way that operation will be performed. So for example, here we are simply saying whenever the car is started, we are displaying the car is started. Okay, right. So once we define this class, okay, as a blueprint for creating any object of similar type, we are going to instantiate an object. We can create n number of objects. We can create n number of objects from the existing class definition. From the existing class definitions. Okay, so this instantaneous of the object is performed using the keyword called as new. So using the new keyword, we can create n number of these objects of type this class. Say for example, here from the class public class n method. So using the new method, we are created this car class type, which is already created here. So this new car, it is creating an object called as my car of type car class. So it creates an object. So using this object my car, we can utilize in our applications or project development as per the requirement of the application. So similarly, we after creating this object my car from the existing class definition car, we can assign any values for the attributes, or we can utilize the all attributes which are defined in the car class definition. So here my car color, we assigned a value called as red, indicates the object whatever just we created the car having a color attribute. Now in this instantiated object, the color is red. So it is the meaning of setting the state of the newly created object. So first we created an object using the new keyword. Then we are setting the state of the object by assigning the required values to the object which we already created. Then we already also created a few methods. The methods are representing the behavior of the object. Here we call the required methods. Here the called as the start. My car is the object. For the my car object, we called a method called as start. It invokes the required behavior. So in the car definition, start definition, you include whatever the way you want to behave this particular object. So based on the object definition, the behavior will takes place. So once you created or defined the class, then instantiation the object, you can utilize the object as per requirement. So whenever we are utilizing this particular object, the object will access required properties and it calls the required methods. So we can access the properties and we can call methods only once we are creating an instance of the particular class called as object. So clearly we need to identify what is the difference between a class and an object. So a class is a blueprint, a object is the real time usage which is instantiated from the created class. Okay, so instance of a class is called as an object, class is the blueprint. Right, so we'll stop the class here. In the next class we'll going to explore in detail each and every characteristics of the OOPS. Thank you.